Assalamualaikum and very good day, student. Today we're going to learn about the normalizing the database design. In this chapter, you're going to learn on what is the normalization and the rules displayed in the database design. You're going to learn about the normal forms. You're going to learn how the normal forms can be transformed from lower normal form to higher normal forms. You also will learn on the concept that normalization and ER modeling are used concurrently to produce a good database designs, and some situations require denormalization to generate information efficiently. So meaning that not only you can use the ARD to create a system, you also can use normalization to create a good system. So what is the normalization actually? Normalization is a process for evaluating and correcting table structure to minimize data redundancies. You have to reduce your data anomalies. What is the data anomalies? There is three types of anomalies. One is the update anomalies, two is a delete anomalies, and the third one is the insert anomalies. Update anomalies mean that a problem when you want to update the records. Insert anomalies is the problem when you want to insert a new record, and delete anomalies is the problem when you want to delete a record. So by using normalization, we can avoid these anomalies. So in this chapter, you will learn about these three normal forms, which is the first normal form, second normal form, and third normal forms. Alright, of course, second normal form is better than first normal form, and the third normal form is better than the second normal form. For most business database design purpose, third normal form is as high as needed in normalization, meaning that if you come up with the third normal form, it's good enough for you to do the system. Highest level of normalization is not always most desirable. I'll give you one situation, company that manage a building project. So this is the info about the company. The company charges its client by billing hours spent on each contract. Hourly billing rate is dependence on employees' positions, and periodically report is generated that contain information such as displayed in the next tables. In this next table, show the report layout for the project. There is information about the project, the employee who managed the project, and also the payment to the employee. By referring to this table, all information is included in one table. So there will be a problem when you want to update, delete, or insert a record. Let's say, for example, I want to edit the employee names. Let's say I want to edit the job class. For example, like electronic engineer, you change the new name to electrical engineering positions. So in this case, you have to edit one by one. Let's say for example, in this table there is a 1000 record regarding electric engineer. So you have to update one by one, meaning that you have to update 1000 times. If you want to delete the record, for example, let's say the employee June is no more in the company, we have to remove the information. So let's say in this table, June record is referring to 20 records, meaning that we have to delete 20 records one by one. This is why you need to do the normalizations. Right? So to do the normalization, you need to know the relation scheme format, how to write down the normalization. We start with the relation name, following with the key attribute and non-key attribute. Key attribute here is referring to primary key. This is the examples. The relation name is the student. The key attribute is the student ID, which is the primary key here. And non-key attribute is student name, gender, and contact number. Alright, this slide is show you the normalization step. We start the UNF. UNF is the unnormal form. In this stage, the table contains redundancy of records. The first normal form, we will separate the single record and redundancy records. Second normal form, we need to identify the partial or functional dependency. So what is the partial dependency? The partial or functional dependency is the dependency of the non-key attribute to the key attribute, for example like primary key or foreign key. So this non-key attribute cannot be explained without the existing of the keys attributes. And the third one, you have to identify the transitive dependency. Transitive dependency is referring to the situation where there are relations between non-key attributes. It can be explained although without the existing of the primary key in the relation scheme. So we try to do one exercise on how to normalize the table. In this sample one, this table contains information about the order ID, order date, product ID, product name, price, quantity, total customer ID and customer name. This table actually is not normal table, so you have to normalize the tables. Alright, so follow this step. So how to write down the UNF? Alright, so remember again the relation scheme. Alright, we have to start with relation name and key attribute and non-key attribute. In this case, try to look at the first column. The first column is order ID, and this order ID actually is referring to the order information. So the relation scheme should be order, and this is the key attribute, which is a primary key, following with the non-key attribute. Alright, now we go to the first normal form. In the first normal form, we have to separate between single record and also the redundancy of record. This is my tips. Alright, so order ID is a primary key. Go to the next one is order date. Go to the next column is product ID. Product ID is also a primary key. So you have to separate order ID as one relation. Product ID until customer name is another relation. So order, we have only these two attributes. Right, and we're going to have a new scheme, which is the product ID. So this product ID actually is referring to the information about the product. So I'm going to have a product here. Right, so type all the keys, the attributes, but don't close first this one. Since from one table, from one relation, you separate into two relations, how to link between order and product? So you need to have one key, which is a foreign key. The question is, where is the location of the foreign key? In order or in the product? Alright, since this is one order can have many products. So many here you can put here like the order ID will be the foreign key, right? So we go to the next one. Second normal form. So in second normal form, But before that, make sure you underline the primary key. Okay. Alright. So for second normal form, you have to identify the transitive dependency. The functional dependency, functional or partial dependency. So we do one by one. So in order, right? The primary key is order ID, right? So the non-key attribute is order date. No other attributes. So this order ID actually is functional dependency to order ID. Without the order ID, you cannot explain the order dates. Alright, so without this one, you cannot explain the order dates. So maybe in the order form there is a same order date, but we don't know this order date is referring to which order ID. So that's why we need to have the order ID here. Right? So the first relation is settled. Right, how about the second one, product? Right, product ID. Okay, who are functional dependency to this product ID? Product name, quantity, no, or totals. Okay, let's say I just put product name first. Right, sorry. Right, how about quantity and total? This quantity and total, of course, these two attribute is functional dependency to product ID, but at the same time, this quantity and total also need order ID to be explained. So you cannot put quantity and total here, right? But customer ID and customer name is still under product ID. Alright, for quantity and total, these two attribute is referring to need to have the product ID and customer ID to be explained. Right. Without existing of one of these attribute, you cannot explain the quantity and total. For example, let's say I remove the product ID. So you know, like for example, like customer ID is number 1, quantity is 2, and total is 100. But we don't know this customer buy which product. Okay, same goes like this. If I remove this customer ID, product ID is 001, quantity is 1, total is 100. But we know this product ID is the quantity buying is 100, the total is 100, for example, but we don't know which customer buy the product. So that's why this quantity need both product ID and customer ID to be explained, so that product, we have a new attribute which is the alright, which is the product ID, product name, customer ID and customer name, and we have a new relationship which is order slash product, and this new relation we have all these attributes. Alright, product ID and product product ID and customer ID, right? Not this one. Sorry. Okay. So this new relationship we have this attribute, which is the product ID, customer ID, quantity, and total. Alright, so the product ID and customer ID is the primary key. Alright, done with the second normal form. For the third normal form, we have to identify the transitive dependency. So what is the transitive dependency? In this case, the relationship between non-key attribute without the primary key also can be explained. Although there is no transitive dependency, so you just write down again, because since there is only one non-key attribute, how about the product? Right, the non-key attribute is a product name, customer ID, and customer name. Okay, so between these three attributes, which attribute that have relation between each other? Alright, the customer ID and customer name have the relationship. Without the product ID also you can expand it. So this is what we call transitive dependency, and then you have to remove from the existing relation. So product now will have a new attribute, which is the right, product ID and product name. Don't close first. Alright, and then you're going to have a new relationship, which is a customer. Right, you're going to have the customer ID, and customer name, and don't forget to put the don't forget to put the foreign key here to link between the product and also the customer. Alright, so in order and product, there is no transitive dependency, so you have to write down again. So in this case, in your system, you're going to have 4 entity, which is order, product, customer, order / product.